Hey everybody, how's it going? I want to just go over some of this worksheet with you. There's some good problems in here. Let's see. So I'm just going to do a few. Let's start with the beginning. Oh yes. Oh yeah. So there are some calculators. That can help you in the book. Here's some calculators here. One for each. This is the one for velocity. I wonder if the other one was on the previous page. I don't see it. That's for the velocity one, and yeah, this is the distance one, or the x. Okay, good. All right, so this worksheet let's look at the beginning here. So it says a car initially at rest accelerates at a constant rate of 1 meters per second squared. Fill in the data table below. Okay, so each second that goes by, we're going to want to calculate how far it's going and its position, and then how fast is it going at that position. So we're going to take these two equations and fill everything in. So acceleration is 1, and then we're going to fill in the time as it goes on. So let's write this down. My favorite website. Okay, so we have two equations. We have velocity and we have position. V naught t plus 1/2 at squared. So we're gonna just, for a, we're gonna use 1, and for time is just gonna cycle, right? So let's do time equals 1. So for time equals 1, we're gonna have, oh yeah, initial velocity is 0. Starts at rest. So V final is always going to be acceleration times time. So 1 times 1 is just 1. What about position? Initial velocity, is that initial velocity? I think it is. Yeah, initial velocity is 0. So this will always cancel out because initial velocity is 0. So all we have is 1/2 times 1 times 1 squared. So 1 squared is 1 times 1 is 1, half of that. So the position is 0.5. Now let's look at time equals 2. Let me check something real quick. Yeah, I think my Bluetooth was off. I hope. So for time equals 2, the final velocity is going to equal acceleration, which is 1, times time 2. So the final velocity is 2. What about the x? 1/2 times the acceleration times 2 squared. 2 squared is 4, so half of that is 2. All right, so let's input those. So the first one is 1 and 0.5. So can I increase. So for 1, my velocity was 1 and 0.5. So 1, maybe change so I know one. Happened. 1 and 0.5. And then what was it for 2? 2 and 2. Can I just make it a default? I wish. Because now I forgot. 2 and 2. 2. And it always goes back. 2. So, this says I'm wrong. Initial velocity is 0. So acceleration times time should be 1, not 2. So I'll have to check that. All right, so this looks good. So then you're going to start graphing these things. Tools. Isn't there a way to insert a drawing or something? No. It'd be nice if I could just draw on these things. Let's border color. Let's see. Highlight color. What's this? Input tools. Why can't I just draw on here? What you might be able to do is, hold on 1 second. I'm gonna pause this real quick. Okay, I'm back. So what we can do, maybe let's try this. We're gonna try to graph. No, that doesn't work. What I'm gonna do, I think I'm gonna try to, I can save this. This would be one way. And then I'll go to my whiteboard and import it. Let's do another new one. Or let's do it here, why not? Insert. See if we can. Interesting. Oh, it's transparent. Okay. So my first ones, so I'm going to start graphing. So my first ones for velocity. Let's see, velocity, we all start at 0, 0, 0. And then position starts at 0. My velocity at time 1 is 1. So velocity time 1 at 1 is 1. So they're in there. My velocity at time 2 is 2. So time 2 is 2. So then you got to keep going. You know, what is this going to look like? Is it going to be straight? Is it going to curve? I don't know. Let's look at position. Position starts at 0, 0, and then I'm getting this from the graph, right? Position starts at 0, 0. And then at time 1, position was 0.5. Time 1, 0.5. Oh, it's very, I'm going to estimate. It's very small. At time 2, I have a position of 2. Time 2, position of 2, that's kind of there. So you have to estimate a little bit. And once you're done, you could bring this over. So I'm going to start connecting the lines. So this one looks like that so far, and this one like that. So let's say this is done. Let's see what this looks like. Okay. So you could do this, copy image, and then just put it over here. Just delete that, and then do that, see? So you'll have your answers there. So we're using this data to make these graphs. One's for velocity versus time, and one's for position versus time. Next, let's do one of these problems. Again, this is just like the example problems we did. All right, a car starting at rest. Okay, so if he starts at rest, so what's given? Initial velocity is 0 because it starts from rest. Anytime you see starts from rest, that means initial velocity is 0. He accelerates at 4 meters per second squared. So acceleration. How far does it travel in 1 second and in 2 seconds? Okay, so they want time equals 1, time equals 2. What's the unknown? They want to know how far. So what equation are we going to use? We're going to use the one for x. X equals velocity times time plus 1/2 at squared. But look, initial velocity is 0, so we don't need that. Because every time you put in a velocity of 0, it cancels out. So all we have left is 1/2 at squared. That might not be the case for every one of these problems. I just randomly picked this problem. So 0.5 times 4 times 1 squared, right? So 1 squared is 1, times 4 is 4, times 0.5 is 2. And that's going to be meters. How about at time 2? It's all the same until you get to the time 2 squared. So 2 squared is 4, times 4 is 16. Half of 16 is 8. And I'm going to take a snapshot of this. You can also do these by hand on paper if you want. And then I'm going to just input it in there, and you can make it smaller. Yeah, so use the guess method and make sure you put boxes around your answers. And that is correct. What is her position? So anytime you ask for a position, you're going to use that. Velocity. Here, I'll start number 4 for you. And then I got to stop because class is about to start. I'm just going to go over all this again. Let's see. Let's do another one. Let's start setting this up. Let's see. Let's big options. Let's see. So this one they're asking for velocity. What is so? Let's see what's given. The driver on the highway traveling at 25 meters. Oh, there's her initial velocity. She's traveling at 25 meters per second. She sees some construction up ahead and brakes for 3 seconds. 3 seconds, that's your time. At a rate of -4 meters per second squared, that's the acceleration. What is her resulting velocity? So that's the unknown. What's VF? I have to plug in my computer real quick. All right. So they want to know what VF is. So VF, so the equation we're going to use is just VF equals your initial velocity plus acceleration times time. So I'll let you guys finish that. So that's the start of it. So you guys have to substitute and solve. So you could pause it, copy down the equation, the givens, unknowns. Yeah, all the rest are the same. It's there's some tricky ones in there, but give them a shot and then we'll go over them again later. I can make this smaller. Let's see. Still too big. There we go. So anyway, that's how you can do this.